organize this lecture in such a short time. We have to especially thank Professor Kuo for promise to prepare and deliver a talk in this very busy schedule. Actually, he just came back to Taiwan last Thursday, so his schedule is very tight. So we appreciate him very much to deliver the talk here. And actually, Professor Kuo is the alumni of our department. After the graduation from NTU-Phys department, he went on to finish a PhD degree from UIUC. And then he had a rich experience both in academic and industrial experience. He has been worked in, say, the Lucent Technology Bell Lab and also Agilent Technology and also LaxNet Corporation. And since October 2002, he went back to Taiwan, National Jiao-Tong University, as a faculty member, and he is an expert in the semiconductor laser and light-emitting device, light-emitting diode device, and his research right now he well known in the wide world. For example, he has been selected as the fellow in several different professional associations, such as the Optical Society Association and also Institute of Engineering and Technology, and also International Society for Optics and Photonics. Besides, he has also received many distinguished awards, such as 吴大有年轻科学奖 and Young Photonic Research Award. And he has published more than 200 ASIAA papers. The total citation more than 6,000 times, and the H index is around 38. So anyway, he's a well-known expert in this field. So the title of his talk today is let's see, is the light-emitting diode innovation for solid-state lighting. Please join us to join me to welcome Professor Kuo.
Thank you, Professor Chen's invitation. And last week, last Tuesday, there's a Nobel Prize announced. Year 2014 Nobel Prize is come to gallium nitride-based blue LED, and three very famous Japanese. Two is Japanese and one is Japanese American. Okay, and I will talk about the story later. Got this award. Okay, and Professor Chen called me, and at that time I was in United Kingdom, and I just replied to Professor Chen, said, no problem, because it's an honor to deliver this kind of lecture back to the home. Okay, I see the NTU-Phys as my home, because I graduated here in 1990. Okay. Okay. Yeah, just Professor Chen told me this is for the whole department. Okay, for the department in the 5 institutes. So show on this figure is a PN junction. Probably insulting to someone. Okay, but it's not really. But for example, when I listen like particle physics, and just like a very college student, it's very difficult to me. And but like LED is pretty simple, because PN junction, I think everybody knows since I think high school people already know PN junction. LED is pretty simple, PN junction. How to operate the LED is just a forward bias. Your your PN junction, or you can just flow the current through the PN junction. If you see the other figures, is a Venn diagram figure. Okay, this I think this on the left side will be the P type, the right side will be N type, and you will supply electron this way and the hole this way, and the electron and the hole will recombine in the junction region in the emitter the wavelength, which is lambda equal to hc over band gap. Okay, then you can achieve what kind of wavelength you can got. Okay, and for gain PN junction 3-5 devices, PN junction made by 3-5 material is pretty interesting. Okay, 3-5 material is a cover range pretty large. It's covered from the UV to very fine infrared. Okay, especially like a red LED or blue LED or green LED, you can select different material and then you can achieve different wavelengths. Okay, but this is a very simple idea. But when I was in college, at that time there's no blue LED. Okay, because the blue LED they use a very difficult material, which means it's gallium nitride. Gallium nitride material at that time, everybody knows if you grow gallium and nitrogen, there are a lot of nitrogen vacancy, and it's very difficult to grow get a very good type of gallium nitride material. That's the reason I think at this time Nobel Prize give to these 3 important Japanese researchers. Okay, and what is LED? LED is a light-emitting diode, and it's a semiconductor chip. Basically, for the blue LED and the blue and green LED, use the indium gallium nitride material, and use red LED or yellow LED, use aluminum indium gallium phosphide. All these compounds are 3-5 compounds. If you can notice, aluminum indium gallium is a group 3, and the phosphide is group 5. And the indium and gallium are group 3. Silicon is group 4. Okay, and the group 3 and the group 5 together, 3 plus 5 will be 8. It's stable element. Okay, and so these two cover these two materials basically cover the visible range of the LED. And for everybody see LED, because most of people see LED already in a packaging form. Okay, especially like it's very close to the Christmas time right now. Okay, and I think starting from November, people start to use the Christmas tree. And if you notice in Christmas tree right now, it's not use a traditional light bulb. It's use LED already. Okay, and most LED look white and blue, and it's all made by this kind of bulb. And for LED packaging, you put the LED chip, either the top one or the bottom one, putting we call it is a cup, and we use a wire bond and bond it to the electrode, and made epoxy on the top. It becomes a LED packaging. And also the other one is a high power packaging, because this one is we call it a mid power or low power, and this is a high power packaging, which we need some CP sink in order to deposition some heat out of the devices. Okay. Okay, and this slide shows about the LED technology. So LED technology started from LED chip, and this is another contribution I will mention from Professor Nakamura. Maybe I should show the picture first. Everybody got show some picture first. Okay. This is I would like to show. This is Professor Akasaki. This is Professor Amano. These two professors from University of Nagoya. Okay, Nagoya Mingu Dashi. And the right one, Professor Shuji Nakamura. Professor Shuji Nakamura used to be the principal engineer for Nichia company. Okay, small company. And he made a huge contribution. He's the first one to commercialize blue LED. Also, he got a very important patent to put the blue LED plus the young phosphorus, become the white LED. These patents, Nichia still own the patent right now. Okay, even Professor Nakamura made a lot of contribution to NTU. Okay, and however, after several years served for NTU, and he got some issue with NTU boss, and he quit and had some lawsuit. Okay, because the patent gallium nitride plus blue LED plus young phosphor, it only got 20,000 Japanese yen for the patent award. Okay, 20,000 Japanese yen, which equivalent to $6,000 $30. Okay, and he feel very angry, so he finally quit NTU and he joined University of California, Santa Barbara. Okay, this is story I will discuss later. Okay, these three guys and so the important thing for LED chip plus phosphor will become the white LED is an invention by Professor Nakamura. Okay, and for the packaging, as I just mentioned, it's a different form of packaging because of different application. Okay, different application like mid power or low power application or high power application. Even some of the device, this kind of packaging they can handle up to 5 watts. Okay, this kind of packaging can handle. If you use some directional light, it's very strong. This can use for projector. Okay, for example like this one, and we are pretty we use this pretty often, this kind of LED, because this kind of package called 35 package. This package is widely used for our computer. Okay, our computer backlight already most of the already use this kind of package. Okay, just show on this slide is a brief history for lighting. Okay, everybody knows the inventor for the light bulb will be Edison. Okay, Edison light bulb, and in 1987, and later on Edison's transfer their technology to General Electric, and in year 1970, okay, the red LED was invented in year 1962 by Professor Colloquia, and I will mention his contribution later. Okay, but he's the I think that time is U.S. the great time. Okay, Professor Colloquia have a lot of resources, so he was in G lab, and I think he told me everyone joined G lab, they got started funding $1 million US for this point. 1962. Okay, 1 million means since it means probably 10 million at this point. Okay, so everybody have a lot of resources. Okay, so his group invented the first visible LED and the first visible laser. Okay, and in 1970, it started have a quantum wave. Okay, it's quantum wave laser. 1978 by MOCVD. 1978. Okay, this is I think it's a good timer. Like some professor joined Bell Lab also got a lot of resources. So later US had several good labs like Kerda Lab, GE Lab, Bell Lab, HP Lab. Okay, I think it's all gone now. Okay, and my friend in HP Lab just told me he got trouble these days because HP decided to split into 2 companies, and they are going to close HP Lab. So it's quite annoying news. Okay, and yeah, and in year 1990s, people already start have a green LED. Okay, but at that time, green LED, the material they use is gallium phosphor doped with nitrogen. It's a kind of between the red bandgap and the infrared bandgap. So efficiency is very poor. Okay, so if you guys remember your first cellular phone, okay, it's still Nokia something. Okay, and Nokia right now they don't make cellular phone also. Okay, so the world is changing a lot. Okay, Nokia first cellular phone they use this kind of green LED as a backlight. Okay, so in early year 1990 they already have 3, but the true green LED and true blue LED was invented in year 1994 or 1993, 1994. Okay, and since then, in I'll show a point here. In 1995, we start have a high brightness blue-green LED, which is a big contribution from Professor Nakamura. Okay, and then in year 2000, the white LED they start got the lumen per watt, about 70 lumen per watt. Right now, in year 2009, it's over 100 lumen per watt, and right now we can get the LED from the shelf or from 7-Eleven. It's 140 lumen per watt or 150 lumen per watt. So the LED since 1995 is changed a lot. Okay. Okay. So so starting from 1907, Henry Rouse start use silicon carbide and they find some blue LED. Okay. And the history for light-emitting diode is discovered 1907, and in year 1972 the first visible spectral LED. 1972 will be the first yellow and high output red LED. And in 1972 HP start to production LED. Okay. The reason why HP start to make production LED, if some people remember, when I was a student, undergraduate student, we learned digital electronics. First one will be 1, 2, 3, 4 by LED. Okay, we made a LED. The bar was made by LED, red LED. So in HP start to use red LED for their calculator. Okay, in year 1970, some early time. Okay, in 1977, the first red LED screen. But over 20 years, is still no high brightness blue LED or red LED. So when I was a senior student, I took a senior project with Professor Y.M. Chen, Chen Yongfang Laoshi. Okay, at that time, Professor Chen told us, if anyone can find the blue LED, you can be rich in the future. Okay, and turns out we just followed. Okay, Professor Nakamura is a Japanese professor. They are pioneer to do this work. Okay, so 1993 to 1995, you can see it start. I was just the first PhD student, 1993. Okay, and when I attended a conference called MIS Material Research Conference, at that time, Professor Nakamura showed the first blue LED. At that time, in San Francisco, the meeting room probably can host about 100 people, but it's occupied more than 400 people in this room. Okay, because it's breaking news to finding the blue LED. Later, blue plus ER cluster become white LED become more and more important. And 1999 it's over 1 watt, and starting from 93, 2006 and up to now, the LED efficiency improve a lot. Okay. So for these figures I got from my previous employer HP. Okay, and for this line showed progress for the green LED, red LED, orange LED. Okay, it's all based on what kind of material? Aluminum gallium indium phosphide. It's starting from gallium phosphide to aluminum gallium indium phosphide. Okay, and starting from this point, it's 1993. First blue LED, and see the efficiency increase quite a lot. And right now, for more than close to 20 years, and the LED efficiency probably increased more than 20 times. Okay, 20 times. So currently the efficiency is over 100. The lab already demonstrated over 200 lumen per watt, and the commercial available is 150 lumen per watt. It's pretty good already. Okay. Okay. Yeah, I would like to mention in this time the Nobel Prize award to 3 professors is a breakthrough in blue, green, and white LED. Okay, and there are several papers published. Okay, it's not on natural science. Okay, you find it. So the first paper for Amano published is they got a p-type doping in gallium nitride magnesium activation by e-beam irradiation. Okay, this paper was published on Journal of Applied JJP. Okay, and the other one, Professor Nakamura's first paper was a patent. He did not publish paper. He published a paper also in 19. This is the first double heterojunction blue and green LED in JJP also. Okay, and then later he published on the applied physics later. Okay, but these papers are very important, and it's a break grounding technology for gallium nitride based LED. So I will quite quickly briefly review brief history for LEDs. Okay, in 1955, ASIAA used to be also very big company. Okay, and also 1961, TI and GE. These are big guys, and they developed first visible LED by Professor Hao-Chung Kuo. In fact, not Professor Hao-Chung itself, is also there's a very important person, Professor Ho. Okay, Dr. Ho also involved in this group. Okay, in 1968, Monsanto developed a commercial available LED for HP calculator, and then later HP acquired the group from Monsanto. Monsanto, the guy, he's the first graduate student from Professor Hao-Chung group. Is called George Crawford. George Crawford, he did the groups and started HP optoelectronic division. Okay, in 1980s, they started this material, aluminum gallium phosphide. Currently is a standard for the high brightness red LED. Or if we use red lasers, they also the standard material for red laser. Okay, 1990s, LED with young phosphor by Nakamura, Akasaki, and Amano. In 2000 for science and lighting. Okay, show us this figure. Yeah, although this time Professor Hao-Chung is a little bit upset because he got every award about the President Award and except the Nobel Prize. Okay, but I think a lot of physics probably the optimal goal is to get Nobel Prize. Right now he already 85 years old. I think this time he got a little bit upset because he did not not included in 3 members for the Nobel Prize. The words just like this way. Okay, so yeah, but he's my advisor's advisor. My advisor is Professor Hao-Chung, first graduate student, and my advisor passed away already. He did. My advisor did a lot of contribution on carbon dope, HPT. Oh, and there's a very famous gallium arsenide material called DS Center, also invented. Also it was his thesis. Okay, Professor Grace Gilman. Okay, so Professor Hao-Chung, I would like to mention, his advisor is very famous professor. Okay, yeah, yeah. In this room, anyone in this room don't know this guy? Okay. I think if anyone in this room don't know this professor, I think you got some problem for the undergraduate study. Okay, because Badin's contribution is very huge. But Badin's contribution is for semiconductor, first semiconductor, and also the BCS theory. Okay, and also I plot here. Okay, Badin's advisor. Eugene Wenger, okay, also Nobel Prize winner, and he's the second graduate student. Okay, William Schaffer. Okay, is we call Badin, Cooper, and Schaffer. Okay, BCS theory is also Nobel Prize. So Hao-Chung is his first student, and the second student. Why we want to do the BCS theory because Schaffer used to do the experimental. Okay, turns out the equipment not working very well, so it turns out to do the theoretical work. And it turns out, and the theoretical work and find out it's very breakthrough in 1960 sometime. And got at that time, Schaffer's PhD thesis got Nobel Prize. So he got the Nobel Prize very young. Okay, only year about 30 to 35, something like this. And there are, because today's talk is talking about some Nobel Prize, so I also want to bring these three guys, okay? These three guys are very, I think without these three guys, I think the world is different, okay? We don't have an iPhone right now, okay? These three guys, Buddy and his boss, okay, and Shockley and Sheriff, okay. Okay, these three guys are very important. Okay, and year 2014, the Nobel Prize in Physics award to these three people. Okay, now here are some quick lists and some citation and contribution for these three Nobel Prize. First is Akasaki. Akasaki in Japan always say he's the father of Japan LED. Okay, he's very high standards. Okay, he got a Japan Tianhuangshan also. Okay, before he got this award. Okay, and before got a Nobel Prize. And his contribution is grow high quality gallium nitride on sapphire substrate and pioneer in low temperature buffer technology. So his major contribution is low temperature buffer. Yeah, the reason why gallium nitride is so tough at that time is people don't have a gallium nitride substrate. If you want to grow any kind of a semiconductor, you want a substrate, okay? And for silicon, it's naturally have a very good silicon substrate. Or germanium, you can refine very good germanium substrate. And even 3-5 devices, gallium arsenide, they can find very good high quality gallium arsenide substrate. But at that time, there's no good gallium nitride substrate. So if you don't have a good gallium nitride substrate, you need to find some host to grow gallium nitride material. However, to grow gallium nitride on sapphire substrate is just by trial and error. Okay, so there's one professor after Professor Nakamura got a Nobel Prize, and he was checked by some reporter. Okay, say this professor say, okay, Nakamura just used trial and error. Okay, and then he got some complaint. Okay, anyway, but in fact, I think if you read the book from Professor Nakamura, he tried over 100 substrates, and it turns out find out that the suitable substrate is sapphire. And for gallium nitride grown on sapphire, the dislocation density is very huge. Okay, dislocation is huge. There's some comment in 1990. Professor Nakamura presented the first paper, and there's a very famous professor. Called Professor Penkov. Okay, Penkov is very famous for if you're doing the semiconductor luminescence. Penkov say, okay, no way this kind of material can do a LED. Okay, it turns out that there is a very high defect density. Defect density is 10 to the 9, 1/centimeter square. It's a very huge, but turns out it still can make a good LED. Okay. Yeah, Professor Amano is Professor Akasaki's student, and yeah, this is also another story. When he doing SEM, okay, and he got at that time like a zinc oxide. Zinc oxide currently people still struggling for the P-type material because oxygen vacancy and also a lot of defect in zinc oxide. So it's very difficult to get a very good zinc oxide P-type material. And I think Professor Amano, when he was a graduate student, he also find this problem. He cannot get a very good OMI contact. But there's one day he doing the SEM for his N-type lousy gallium nitride material. It turns out that because he worked harder than other people. Normally people probably study about 10 minutes or 20 minutes to finish the E-beam. Because SEM we use E-beam to search to get this image of the material, okay. And turns out he used about 2 hours, okay. He find out a lot of strange stuff, and it turns out after he unload the wafer, and normally people unload the wafer, they just put it in the garbage or put it in the sample stack. They will not check. But Professor Amano, he did the whole measurement again. Okay, whole measurement again. It turns out it become P-type. Okay, it's quite exciting, and the P-type can persist pretty long, and he find out some way to get very good P-type material. Okay, this is his contribution for get the P-type gallium nitride. Now this is very big groundbreaking